let's show that the equation x cubed plus 2x plus 1 equals 0 has exactly one real solution by using the mean value theorem. I'll probably use Rolle's theorem, which is just a special case of the mean value theorem. If we want to show that there is exactly one solution, that means that we need to show two different things. First off, we have to show that there's at least one solution. Next up, we have to show that there cannot be two solutions. If you have at least one and you can't have two, and we're talking about numbers of solutions, so that's natural numbers, then you have to have one. We're going to have to use intermediate value theorem and Rolle's theorem here. So let's start by stating some of the conditions or hypotheses we already know are fulfilled. So first up, f of x equals x cubed plus 2x plus 1 is continuous on negative infinity to infinity and differentiable on negative infinity to infinity. We need the continuous and differentiable for a part of Rolle's theorem, and we need the continuous for part of the intermediate value theorem. Intermediate value theorem is going to help us with this first step, where we need to show that there's at least one solution. We'll do this again using the intermediate value theorem. So we know that f of x is continuous, so that helps us out. Now we need to state the other conditions. So x cubed plus 2x plus 1 equals 0 has a solution if there exists two numbers a and b such that we end up on either side of that 0. So, such that f of a is greater than 0 and f of b is less than 0. Now we need to find any numbers a and b that fulfill this requirement. Sometimes this takes a bit of guessing and checking. If you're guessing and checking out of nowhere, 3 good x values to check, simply because they're easy to evaluate for most functions, are -1, 0, and 1. So f of -1 gives us -2. F of 0 gives us 1. And we already have 2 outputs that are on either side of 0, but just for completion's sake, if we maybe had guessed 1 first instead, f of 1 would be 4. But as I said, we have 2 inputs that give us outputs on either side of 0. So there is a real solution. To x cubed plus 2x plus 1 equals 0 on the interval -1 to 0 by the intermediate value theorem. Now that we've shown there's at least one solution, the next step is to show that there cannot be two solutions. So step 2, show there cannot be 2 solutions. Using, I prefer, Rolle's theorem. Okay, so this is going to be something called a proof by contradiction. So we'll suppose something is true, and then we're going to show that that leads to something that is false, which means that the original thing we said was true can't be true. So we're going to suppose that x cubed plus 2x plus 1 equals 0 has 2 solutions. And we'll call these solutions A and B. Now, we know that it doesn't have 2 solutions, but we're just like, suppose, maybe we'll pretend it has 2 solutions. Now, if it has 2 solutions, that means that the output for A and the output for B are both 0. So when we input A, we output 0. When we input B, we output 0. Now, this is some sort of polynomial, so it's doing something like this. So if we have our 2 solutions, solution A and solution B, that means that since this is a continuous function, and since it's differentiable between A and B, and since f of A equals f of B, there must exist a number which we would call C, on that interval from A to B, such that f prime of C is equal to 0. We've satisfied all of the conditions of Rolle's theorem. There has to be some sort of f prime of C equals 0. So let's find that f prime of C equals 0. So there's got to be an f prime of x, which we'll find, and that will be 3x squared plus 2 is equal to, there must be some sort of x where this is equal to 0. So let's find that x. We'll subtract 2 from each side, so we get that 3x squared is equal to negative 2. So that means that we have some sort of x squared is equal to negative 2/3. And that just can't happen. The equation x squared equals negative 2/3, and you might have recognized it at this step, at the 3x squared equals negative 2, and that works too, has no real solution. So we have arrived at a contradiction. There cannot be 2 solutions. Wonder how far I zoomed away this time. Okay. Therefore, bringing our 2 pieces together, we know there's at least 1, and there cannot be 2. So therefore, x cubed plus 2x plus 1 equals 0 has exactly one real solution.